July 12, 1969, astronaut Neil Armstrong descended the ladder of the lunar module and spoke words that were to change human history forever. A small step for a man, a giant leap for mankind. The whole world froze. It seemed the era of space empires had begun. The moon would become the first colony, then Mars, then the stars. But do you know what happened next? Nothing. Absolutely nothing. The last human left the moon in December 1972, and since then, not a single foot has stepped there. 50 years of silence, 50 years while we built skyscrapers, created the internet, sent robots to Mars, but ignored the moon like a forgotten toy. You were told we abandoned the moon because there was not enough money, or there was nothing to do there, or if you believe conspiracy theorists, that aliens drove us away. All of this is a lie. We abandoned the moon because the Apollo program was the most expensive dead end in the history of engineering. It was a technological sprint that was physically impossible to turn into a marathon. The laws of physics made the lunar program an economic absurdity, and we understood this perfectly well by the mid-70s. The moon was not worth the money required to return there. There was nothing valuable there, nothing that would justify the monstrous price of a one-way ticket. But now we are returning, and we are returning not for the sake of flags and prestige. We are returning because everything has changed. We found what turned a dead stone into a strategic resource. We found water. And from that moment, the moon ceased to be a museum of the space race and became the field of a new battle. The battle for the 8th continent, a battle that will determine who will control access to the rest of the solar system. The United States versus China, the state versus corporations, laws against the void. Welcome to the most important race of the 21st century. Before we dive into this story of how humanity learns from its mistakes and begins a new chapter of space expansion, support the Sleepy Scientist channel with a subscription and a like. This way you will not miss other materials about how science and geopolitics collide on the frontier of the possible, shaping our future among the stars. So let us start with why the Apollo program was the greatest engineering triumph and simultaneously an economic catastrophe. Imagine that you need to get from Moscow to Vladivostok, but every time you travel, you must burn the train after arrival. Not just write it off, but literally destroy it, and then build a new train from scratch for the next trip. It sounds crazy. That is exactly how the Apollo program worked. Each mission required the construction of a giant disposable Saturn V rocket, the most powerful rocket in human history. It weighed almost 3,000 tons at launch. Of those 3,000 tons, only a tiny capsule weighing about 5 tons returned to Earth. Everything else burned up, sank in the ocean, remained in orbit or on the moon. 99% of the rocket was consumable material. Why so? Because there is a fundamental law of cosmonautics called the Tsiolkovsky equation. It is not just a formula in a textbook. It is a tyranny that determines the entire space industry. The point is that the more payload you want to deliver, the exponentially more fuel you need. And this fuel also has mass that needs to be accelerated. It turns out to be a vicious circle. To deliver 3 astronauts with equipment weighing several tons to the moon, you need a rocket weighing 3,000 tons. This is a ratio of 1 to 1,000. Imagine that every time you want to send a package weighing 1 kilogram, you need to spend a ton of resources. This is the reality of space flights. The Apollo program cost $140 billion in modern prices. Each lunar mission cost about $1 billion. For this money, 12 people flew to the moon. They spent a total of 3 days there and brought back 380 kilograms of lunar soil. If you calculate the cost of 1 gram of lunar rock, it turns out to be about $300,000 per gram. Gold costs $60 per gram. Even the rarest isotope on Earth is cheaper. It was economically absurd. The program worked only because it was a political project of the Cold War era. The Soviet Union launched the first satellite and the first human into space. The United States could not lose. Kennedy set the task of landing on the moon before the end of the 60s, and money poured in like a river. At the peak of the Apollo program, 400,000 people worked on it. It consumed 4% of the United States federal budget. But as soon as the race was won, interest evaporated. The moon was reached, the flag was planted, prestige was restored. Why continue spending billions? Scientific value. Scientists received soil samples, studied geology, confirmed the theory of the moon's formation as a result of a collision between proto-Earth and an object the size of Mars. This was enough. Resources, they were not found there. Lunar regolith, basaltic rocks, nothing valuable. Water. Back then, they thought it was not there. A dry, dead world without an atmosphere. A base on the moon. For what? So that astronauts could sit in a bunker, go out for walks in spacesuits, and count craters. This would cost hundreds of billions annually. Politicians quickly realized that the game was not worth the candle. And here begins the key moment that explains everything. The problem was not in political will and not in technology. The problem was in physics. The Apollo program worked at the limit of the possible. The Saturn V rocket was a marvel of engineering, but its production was so complex and expensive that after the end of the program, the technology was simply abandoned. Blueprints were scattered across archives, equipment was disposed of, specialists went their separate ways. By the 80s, NASA could no longer build a new Saturn V, even if it wanted to. Knowledge was lost. It is as if humanity forgot how to build the Egyptian pyramids, only even more absurd because it happened in 20 years. Instead of the moon, NASA bet on space shuttles, reusable ships that were supposed to make space cheap and accessible. The idea was beautiful. Fly to orbit and back like on an airplane, transport cargo, build stations. But here too, physics turned out to be cruel. The shuttles were expensive, dangerous, and eventually 2 out of 5 exploded, killing 14 astronauts. The program was closed in 2011, and the moon remained overboard. Too far, too expensive, too pointless. The Soviet Union also tried to get to the moon. Their N-1 rocket was supposed to compete with Saturn V. 4 launches, 4 explosions. The program was closed. The Soviet Union switched to orbital stations. Then the Union collapsed, and the moon was forgotten completely. The 90s and 2000s passed under the sign of low Earth orbit. International Space Station, cargo ships, and satellites. The moon turned into a nostalgic relic. Old people told children how people were there once long ago, and children did not believe it. But in parallel, something important was happening. Scientists continued to study the moon remotely, launched automatic probes, mapped the surface, analyzed soil composition with instruments. And somewhere in the late 90s, strange data began to appear. Radar observations showed anomalies in the polar craters of the moon, something that reflected radio waves in an unusual way. This could be ice, but everyone was skeptical. The moon has been bombarded by solar wind and meteorites for billions of years. Any water should have evaporated into space. There is no atmosphere. There is nothing to hold molecules. The logic seemed ironclad. However, in 2008, the Indian mission Chandrayaan-1 sent a device to the moon with an American instrument that registered infrared radiation. And this instrument detected signs of water molecules and hydroxyl groups on the surface. The scientific community became alert. Then in 2009, NASA launched the LCROSS mission. They specifically accelerated the booster block and crashed it into Cabeus crater at the south pole of the moon. The impact threw up a plume of dust tens of kilometers high. And in this plume, instruments recorded water, not traces, not hints, but real water. About 100 kilograms in the ejected material. Extrapolation showed that in permanently shadowed craters at the poles, there could be ice, lots of ice, millions of tons. This discovery turned everything around because water on the moon means more than just scientific interest. Water on the moon is fuel, oxygen, protection from radiation, construction material. Water is the key to turning the moon from a useless rock into a strategic outpost. Let us break down why. First, water is fuel. If you pass an electric current through water, it decomposes into hydrogen and oxygen. The process is called electrolysis, and it can be carried out right on the moon using solar panels. Hydrogen and oxygen are components of rocket fuel. Mix them in a combustion chamber, ignite them, and you get thrust. These are the same components on which the main engines of space shuttles flew. Imagine that now there is no need to bring all the fuel from Earth. You fly to the moon, refuel there with hydrogen and oxygen, and set off further to Mars or the asteroids. The moon becomes a space gas station, an orbital refueling point. This radically changes the economics of space flights. To understand the scale of changes, imagine this analogy. You are traveling from Moscow to Vladivostok by car. If you need to carry all the gasoline with you from the very beginning, the car turns into a fuel truck, and you spend most of the fuel just on transporting the fuel itself. But if there is a gas station halfway, you can take a minimum, fly to it, refuel, and then drive light. The moon is that very gas station halfway between Earth and the rest of space. The gravity of the moon is 6 times weaker than Earth's, and there is no atmosphere. Launching from the moon is tens of times cheaper than from Earth. If you can produce fuel on the moon from local resources, the economics of missions to Mars, to asteroids, to Jupiter's moons changes completely. Second, oxygen. Not only for rockets, but also for breathing. Astronauts consume about 1 kilogram of oxygen per day. If you plan a long-term base on the moon, bringing all the oxygen from Earth is insanely expensive. 1 kilogram of cargo to the surface of the moon costs about $50,000. If the base is designed for 10 people for a year, that is 3.5 tons of oxygen, $175 million just for air. But if you can extract oxygen from water or even from lunar regolith containing oxides, the cost collapses. You create a closed life support system. The carbon dioxide that astronauts exhale is processed back into oxygen. Water is split, used, collected again. The base becomes self-sufficient. Third, protection from radiation. The moon has no magnetic field and no atmosphere, so the surface is constantly bombarded by cosmic rays and solar wind. The radiation dose on the surface is about 250 times higher than on Earth. Apollo astronauts spent only a few days there. It was tolerable. But if you plan to live there for months, protection is needed. Thick walls of metal are too heavy to carry. Lunar soil is possible but difficult to build with. Water is an ideal option. Hydrogen atoms absorb radiation perfectly. A wall of water 1 meter thick protects almost as well as several meters of concrete. You can build cisterns around residential modules, fill them with lunar water, and get cheap, effective protection. Water simultaneously serves as a supply in case of leakage, a reservoir for fuel production, and a radiation shield. Fourth, construction. Mix lunar regolith with water and you get something like concrete. Not exactly concrete, but a material that can be molded, compacted, used for construction. There is no wood on the moon, little metal. Plastic must be brought from Earth. But there is an infinite amount of regolith. It covers the entire surface in a layer of several meters. If there is water, you can make blocks, print structures on 3-dimensional printers, build roads, landing pads, walls. Water turns dust into construction material. Fifth, agriculture. Plants need water. If you want to grow food on the moon so as not to depend on constant supplies from Earth, you need a closed ecosystem. Hydroponics, greenhouses under domes, LED lighting, carbon dioxide from astronaut breathing. All this is possible, but the key component is water. On Mars, there is water ice under the surface. On the moon, now there is too. This makes both worlds candidates for colonization. The discovery of water on the moon restarted the lunar race. But now it was a different race, not for prestige, but for resources. And in this race, not only states but also private companies participate, because if the moon is a gas station, it means you can make money on it. SpaceX, Blue Origin, dozens of startups look at the moon and see money. NASA launched the Artemis program. The goal is to land astronauts at the south pole of the moon by the mid-20s and build a long-term base. China launched the Chang'e program. They have already landed several probes, including the first device on the far side of the moon. They plan to build an international scientific lunar station jointly with Russia by the end of the 30s. The European Space Agency is developing the concept of a lunar village. India, Japan, South Korea, the United Arab Emirates have all announced plans for lunar missions. But the most important thing is not the number of participants, but their motivation. In the 60s, they flew for science and pride. Now they fly for control over resources, and resources on the moon are distributed unevenly. Water is concentrated in permanently shadowed craters at the poles. The South Pole is especially rich. Shackleton Crater, Cabeus Crater, Nobel Crater. All of them are in a region that never sees sunlight. The temperature there is -200 degrees. Ice has been preserved for billions of years, protected from evaporation by cold and shadow. But near these craters, there are heights that are illuminated almost constantly, peaks of eternal light. You can put solar panels there that will work 90% of the time. An ideal place for a base, simultaneous access to energy and to water. And here the problem begins. There are few of these ideal places. There might be a dozen peaks of eternal light, maybe 2 dozen, but certainly not hundreds. If one country or company occupies such a place and builds a base there, all others will find themselves at a disadvantage. It is like seizing the only source of fresh water in a desert. Technically, others can find water somewhere else, but it will be more expensive, more difficult, more dangerous. Whoever occupies the best positions first will gain a strategic advantage, and no international laws regulating this exist. The Outer Space Treaty of 1967 is the main document defining the rules of behavior in space. It prohibits the placement of weapons of mass destruction in orbit and on celestial bodies. It prohibits national appropriation of the moon or planets. Space is declared the heritage of all mankind. But this treaty was written when no one had yet reached the moon, and no one imagined that there could be valuable resources there. The treaty says nothing about who has the right to mine and use lunar resources. Can a private company fly in, build a mine, extract water, and sell it? Technically, this is not appropriation of territory, but actual control. The United States in 2020 launched the Artemis Accords. This is a set of principles for the peaceful exploration of the moon. They speak of transparency, mutual assistance, system interoperability, protection of historical sites like the Apollo 11 landing site. But there is also a point about safety zones. If someone builds a base, they can declare a safety zone around it where others cannot enter without permission. This sounds reasonable, preventing accidents, collisions, equipment damage. But in essence, it is a way to consolidate control over territory without calling it appropriation. China and Russia refused to sign the Artemis Accords. They believe it is an attempt by the United States to establish its own rules bypassing the UN. Instead, they proposed their own concept of international cooperation, but their allies are mostly countries unfriendly to the West. The result is 2 blocks, 2 parallel systems, as in the times of the Cold War. And here we approach the most frightening scenario. What if 2 powers claim the same ice deposit? What if an American base on a peak of eternal light is adjacent to a Chinese base 5 kilometers away, and both try to extract water from the same crater? International space law does not provide mechanisms for resolving such disputes. On Earth, there are borders, customs, courts, armies. In space, none of this exists. The moon could become the first extraterrestrial theater of military operations, not because someone wants it, but because there is no system that could prevent it. But let us stop for a second and see how realistic a conflict on the moon is. War in space is not fiction from movies. It is not lasers and starfighters. It is extremely slow, expensive, inefficient operations. Delivering a soldier to the moon costs tens of millions of dollars. He will be vulnerable, dependent on life support systems, limited in movement. Pierce the spacesuit, one shot, and the person is dead. Damage the residential module of the base. Explosives, fragments, depressurization. Everyone inside dies. A base on the moon is an incredibly fragile structure. It depends on constant supplies from Earth, on the operation of solar panels, on water and air filtration systems. One sabotage, and everyone is dead. But it is precisely this fragility that makes the moon a zone of potential conflict, because an army is not needed to destroy a lunar base. One unmanned device that crashes into solar panels, or a hacker attack that shuts down control systems, or a small explosion that showers equipment with regolith is enough. Lunar dust is an engineer's nightmare. It is electrostatic, sticks to everything, clogs moving parts, scratches optics, penetrates tight connections. If you deliberately raise a cloud of dust around a base, it can knock it out of action for weeks. Imagine this scenario. Year 2035. The United States built the Artemis base at the south pole of the moon near Shackleton Crater. 6 astronauts live there, mining ice, producing oxygen and hydrogen, testing technologies for a future Mars mission. 10 kilometers away is the Chinese Tiangong moon base with 8 taikonauts. They are doing the same thing. Both bases use the same crater for ice mining. Technically, the moon is large enough and there is enough ice for everyone. But the Chinese begin active drilling operations that create vibrations damaging American equipment. The United States files a complaint with the UN. China says that the moon has no borders and they have the right to work anywhere. Tension grows. A month later, the main generator fails at the American base. Technically, it could have been an accident, but the Americans suspect sabotage. A drone could have flown at night and damaged the system. There is no evidence. CCTV cameras record a shadow, but it is impossible to identify the object. The United States sends a lunar rover to the Chinese base demanding an inspection. China refuses, citing the sovereignty of its mission. The rover approaches. Chinese robots line up, blocking the path. This is not a military operation. It is just 2 groups of machines that cannot agree. But if one of them pushes the other, and this causes damage to critical equipment, escalation will begin. One of the Chinese rovers crashes into the American one. Accident or intentional, it is unknown. The American rover flips over. Solar panels are destroyed. The United States regards this as an act of aggression. They activate a secret military satellite in lunar orbit. It releases a small projectile that destroys the Chinese communication antenna. China loses contact with the base. Taikonauts go into emergency mode. They do not know if it was an attack or an accident. They assume the worst. One of their rovers heads for the American base. Astronauts see this on radar, panic, and activate the defensive system. An impulse radar device that jams electronics. The Chinese rover stops, but its systems are damaged. Now both sides believe the other attacked first. Contact with Earth goes with a delay of a few seconds, but enough for the military on both sides to start preparing for the worst. The United States announces that the Chinese base poses a threat. China states that the Americans violated international law. An emergency meeting is convened at the UN, but while diplomats argue, a tragedy occurs on the moon. The Chinese, fearing further attack, launch a small rocket that was supposed to be used for geological intelligence in the direction of the American base. Not to hit, but to show force. The rocket misses the base, but its liquid fuel engine leaves a trail of hot gases that damage the American solar panels. The base switches to emergency power. Astronauts realize that if there is no repair within 48 hours, they will have to evacuate. But the evacuation ship is not ready for launch. time is needed. The United States makes a decision on active defense. They use a satellite in orbit to drop several containers with metal rods, just inert blanks that fall under the action of lunar gravity. This weapon is called kinetic. No explosives are needed. An impact speed of several kilometers per second is enough to pierce any armor. One of the rods hits near the Chinese base, throwing up tons of regolith that buries the equipment. The second rod hits a robotic arm used for ice mining, destroying it. China interprets this as a full-scale attack on a civilian base. They activate a secret laser that was supposed to be used for testing communications and direct it at the American evacuation ship, damaging the propulsion system. Now the American astronauts cannot leave the moon. They find themselves hostages. A diplomatic crisis begins on Earth. The United States demands immediate de-escalation. They accuse China of attempting to kill astronauts. China says it acted in response to American aggression. The situation is on the brink of war. But both sides realize that a real war on the moon is impossible, because even if you destroy the enemy base, you will not get control over the moon. You will simply lose billions of dollars and political capital. The moon is too big to be occupied and too expensive to fight for. The conflict ends with negotiations, and the UN imposes a moratorium on any active operations on the moon for 6 months. An international commission is created to investigate the incident. The United States and China accuse each other, but there is no public evidence. Astronauts are evacuated on a backup ship sent from Earth. The Chinese base continues to work, but with a minimum crew. Both sides realize that such a scenario cannot be repeated. Negotiations begin on the creation of an international lunar treaty that would establish clear rules for resource extraction, safety zones, and dispute resolution mechanisms. This is a hypothetical scenario, but it is based on real risks. The moon becomes a zone of potential conflict not because someone wants war, but because the legal system does not keep up with technological capabilities. And the more countries and companies start working on the moon, the higher the probability of incidents. Collisions of rovers, equipment damage, disputes over the right to mine. All this can get out of control if there is no international management mechanism. But let us now look at the other side of the issue, the economic one. Because all these geopolitical games make sense only if the lunar economy is real. And is it real? Can you really make money on the moon? Imagine that you are a space company. You have a rocket that can deliver cargo to the moon. You have robotic equipment that can mine ice and process it into fuel. Your business plan is this. You build a fuel production plant on the moon. Every month, the plant produces 10 tons of liquid hydrogen and liquid oxygen. You sell these 10 tons to other companies and agencies that send missions to Mars, to asteroids, to Jupiter's moons. The sale price is $50,000 per kilogram. This is cheaper than bringing fuel from Earth, where the cost of launching into orbit is about $100,000 per kilogram, taking into account all stages of delivery. Your monthly income is $500 million. It sounds fantastic. But in fact, the economics can work. The key point is reducing the cost of delivery to the moon. Now delivering a kilogram to the surface of the moon costs about $50,000. But companies like SpaceX are working on reusable systems that can reduce this cost to $10,000 or even $5,000. If you build a lunar plant that weighs 100 tons, the initial investment will be $500 million just for delivery. Plus development and production of equipment could be another billion. Total $1.5 billion. If the plant produces 10 tons of fuel per month and sells it at $50,000 per kilogram, the income is $500 million a month, payback in 3 months. Even if you take into account operating costs, equipment replacement, risks, the project pays for itself in a year or two. After that, pure profit. And this is provided that there is a market of buyers. There is a market. NASA plans to send people to Mars in the 30s. Each Mars mission will require hundreds of tons of fuel. If half of this fuel can be refueled on the moon, the savings are huge. Companies mining resources on asteroids need fuel for maneuvering. Tourist flights around the moon are already being sold, and they also need refueling. Satellites in high orbits used for communication, navigation, and Earth observation periodically need refueling for orbit correction. If there is cheap fuel on the moon, you can send a tanker, refuel the satellite, extend its service life for decades. This is billions of dollars in savings for satellite operators. Besides fuel, there are other resources on the moon. Regolith contains oxides of silicon, aluminum, iron, titanium. These elements can be extracted using chemical processes and used for the production of solar panels, metal structures, electronics. So far, it is cheaper to bring everything from Earth, but if an industrial base appears on the moon, the balance will change. Imagine a space station that is assembled in lunar orbit from components produced on site. There is no need to launch hundreds of tons of metal from Earth. You mine metal on the moon, melt it in vacuum furnaces using solar energy, and send it into orbit. Gravity is 6 times weaker. Energy for launch is minimal. Helium-3 is an isotope that is rare on Earth, but relatively common in lunar regolith. It was brought there by the solar wind over billions of years. Helium-3 is seen as a potential fuel for future thermonuclear reactors. The fusion reaction of helium-3 with deuterium produces a huge amount of energy and gives almost no radioactive waste. The problem is that thermonuclear reactors on helium-3 have not yet been created. This is a technology of the next century if it will be implemented at all. But if it works, the moon will become a source of the most valuable fuel in the universe. A kilogram of helium-3 can theoretically provide energy for a small city for a year. There are millions of tons of it on the moon. But even without helium-3, the lunar economy makes sense if the moon is considered as an intermediate base. Each mission to deep space launched from Earth must overcome the gravitational well of our planet. This is the most energy-consuming part. If production, assembly, and launch of spacecraft are moved to the moon or its orbit, savings on fuel will be orders of magnitude higher. The moon becomes a shipyard where interplanetary ships are built. Raw materials are mined on site. Energy is from solar panels or from compact nuclear reactors. Labor is robots and a small number of people for control. The ship is assembled in lunar orbit, fueled with lunar fuel, and sent to Mars. Only what cannot be produced on the moon, high-tech electronics, medicine, fresh food for the crew, is brought from Earth. Everything else is local. This scenario is called the Lunar Industrial Revolution. And it is not fiction. Technologies for this exist, or are being developed. Robots capable of working in extreme conditions. Systems for mining and processing regolith, 3-dimensional printers printing metal parts from powder, closed life support systems where nothing is lost, everything is recycled. The problem is not in technology. The problem is in initial investment and in coordination of efforts. Who will finance? The state, private companies, or both? NASA launched the Artemis program with a budget of about $100 billion for the next decade. This is a lot, but not enough to build a full-fledged industrial base. Private companies are ready to invest, but they want guarantees of return. No one will invest billions in a project that can be blocked by political decisions or competitors. Legal certainty is needed. International treaties are needed that protect investments, define property rights, and establish rules for competition. While this is not there, the lunar economy remains in limbo. States spend money on prestigious missions. Companies experiment with technologies. But real large-scale development does not occur. And here again, geopolitics surfaces, because whoever is the first to create a working economic model on the moon will gain a huge advantage. This is like the discovery of America or the Industrial Revolution. A country or a block of countries that control lunar resources and infrastructure will be able to dictate terms to everyone else. This does not mean direct occupation, but it means technological and economic dominance. China understands this. Their lunar program is ambitious and consistent. The Chang'e 4 mission, for the first time in history, landed a device on the far side of the moon in 2019. The far side is interesting because it is never visible from Earth due to tidal locking. There is no direct radio communication. A relay satellite is needed. China launched such a satellite and proved it could work in difficult conditions. Chang'e 5 returned lunar soil samples to Earth in 2020. Chang'e 6 is planned to be sent to the South Pole for ice reconnaissance. Chang'e 7 and 8 will test resource extraction and base construction technologies. By the end of the 30s, China plans to have a permanent inhabited station on the moon. Russia announced a partnership with China in this project. Roscosmos will provide landing and life support technologies, experience of long-term orbital missions. China will provide financing and production capacities. Together, they create an alternative to the American Artemis program. This is not a new Cold War, but it is definitely competition for influence. Europe, Japan, India oscillate between the two blocs. The European Space Agency cooperates with both NASA and Roscosmos. Japan is traditionally an ally of the United States, but also develops relations with China. India is independent. They have their own Chandrayaan program, and they do not want to choose a side. And what about private companies? Elon Musk's SpaceX is focused on Mars, but their Starship rocket, which is being developed for Mars missions, can also be used for the moon. Jeff Bezos's Blue Origin directly stated that their goal is to create lunar infrastructure. They are developing the Blue Moon lander, which will be able to deliver several tons of cargo to the surface. Bezos speaks of the concept of transferring heavy industry from Earth to space to preserve our planet as a living zone, while conducting all polluting production on the moon or on orbital stations. This is a long-term vision, but it is technically feasible. There are also dozens of startups developing niche technologies for the lunar economy, companies making robots for ice mining, companies designing lunar residential modules from inflatable structures protected by regolith, companies developing waste processing systems so that nothing is thrown away, companies planning to create a lunar internet, a satellite network around the moon for constant communication between bases and with Earth. This is an entire ecosystem forming around the idea that the moon will become habitable and economically significant. But let us return to reality. All these plans depend on one critical factor: the reliability of technologies. The moon is an extremely hostile environment. The temperature ranges from plus 120 degrees by day to minus 170 at night. A lunar day lasts 14 Earth days. The night is the same. If your base depends on solar panels, 2 weeks of darkness is a problem. You need huge capacity batteries or nuclear reactors. Radiation is a constant threat. Without a magnetic field and atmosphere, cosmic rays and solar flares hit the surface directly. During a major solar storm, the radiation dose can be fatal in a few hours. Astronauts must have shelters with thick walls where they can hide. Lunar dust is a separate problem. It is not like Earth dust. It is sharp like shards of glass because there is no wind and water to smooth it. It is electrostatically charged, sticks to spacesuits, tools, and seals. Apollo astronauts complained that dust penetrated the capsule. Despite all precautions, it smelled like gunpowder, irritated lungs, and scratched helmet visors. If you plan a long-term presence, the dust problem must be solved. Perhaps airtight airlocks where spacesuits are cleaned before entering the living area. Perhaps special coatings that dust does not stick to. Microgravity is another factor. On the moon, gravity is 6 times weaker than Earth's. This is not weightlessness like in orbit, but it is enough to affect health. Bones lose density, muscles atrophy, the cardiovascular system weakens. Astronauts on the International Space Station train for 2 hours a day to minimize these effects. On the moon, the problem is smaller, but it is there. Long-term stay can lead to irreversible changes. Children born on the moon, if at all possible, may have problems adapting to Earth's gravity. Psychological factors are also critical. Living in an enclosed space surrounded by a hostile environment without the ability to go out for fresh air, see greenery, or feel rain is a huge stress. On the International Space Station, astronauts spend several months, and they have constant communication with Earth, the ability to see the planet through the porthole. On the Moon, you see a black sky, gray dust, and Earth, a small blue ball hanging over the horizon. This can cause depression, anxiety, conflicts within the team. Psychologists, support programs, possibly virtual reality simulating Earth landscapes are needed. But despite all these difficulties, the Moon is our only real chance to learn to live outside Earth. Mars is too far. A flight there will take months. Return is possible only after 2 years when the planets approach each other again. If something goes wrong, help from Earth will not come. On the Moon, Earth is 3 days away. If an emergency happens, a rescue mission can be sent. The Moon is a training ground. We learn to mine water, produce fuel, build shelters, grow food, live in a closed cycle. All this will be useful on Mars, on Jupiter's moons, on asteroids. But first, we need to prove that it works on the Moon. And here we approach a philosophical question. Why explore space at all? For resources, for prestige, for the survival of the species. All these reasons are true, but there is one more, deeper one. Humanity has always strove beyond the horizon. We have settled all the continents of Earth, crossed oceans, climbed mountains, descended into the depths. We cannot stop. It is in our nature. Space is the final frontier. And if we do not cross it, we will remain on one planet, vulnerable to asteroids, supervolcanoes, climate change, nuclear war. All eggs in one basket. Space colonization is an insurance policy. If something happens to Earth, humanity will survive on the Moon, on Mars, on stations, in the asteroid belt. We will become a multi-planetary species. And this is not fiction. It is a plan. But to implement this plan, you need to start small. And the Moon is small. It is close. We have already been there. We know it is possible. Now we need to take the next step. Turn short-term visits into a permanent presence. Build a base that will not close after a few years but will grow. Bring the population to 10 people, then to 100, then to 1,000. Create a closed ecosystem where everything is produced on site. Launch a lunar economy that pays for itself. And when this happens, the Moon will cease to be a NASA or Roscosmos project. It will become part of human civilization. The 8th continent, a place where people live, work, and raise children. Of course, this will not happen in the next 10 years, maybe not in the next 20, but the process has started. Each mission, each robot, each experiment is a brick in the foundation. The Artemis program plans to land astronauts at the South Pole by the mid-20s. If everything goes according to plan, this will be the first step. Then they will build a temporary base, then a permanent one. China is building its base in parallel. Maybe at some point they will join forces, or maybe they will compete. Time will tell. But one thing is clear. The Moon is no longer a forgotten relic of the past. It is the future. Now let us talk about what life on the Moon will look like. Not in sci-fi movies, but in reality. A lunar base is not a giant dome with parks and skyscrapers, at least not in the first decades. It will be a set of small modules, partially buried in the ground or covered with a layer of regolith for protection from radiation. The modules are connected by airtight tunnels. Inside it is cramped, functional, like on a submarine. Every square meter is used to the maximum. Sleeping cabins the size of a prison cell, a common area for eating and resting, laboratories, workshops, a medical block. Everything is sterile, lit by artificial light, smells of recycled air. Astronauts will spend most of their time inside. Surface exits are limited by radiation and spacesuit wear. Each exit is a risk. A spacesuit is a complex life support system that can break. If it depressurizes in a vacuum, you have seconds before losing consciousness. so exits are planned carefully, always in pairs with backup systems. Working on the surface, mining ice, repairing equipment, installing new modules is hard physical labor in conditions of low gravity and limited mobility. After returning, hours are needed for cleaning from dust, checking systems, recovery. Food will be monotonous. Mostly freeze-dried products, canned goods, something grown in hydroponic greenhouses, lettuce, tomatoes, maybe potatoes. Meat is a rarity brought from Earth. Maybe in the future, they will learn to grow cultured meat from cells, but this is still an experimental technology. Water is recycled completely, urine, sweat, condensation from the air. Everything is filtered and cleaned. This sounds unpleasant, but in fact, the water after purification is cleaner than in most Earth tap waters. The problem is that it is psychologically hard to drink water knowing its origin. Communication with Earth will be with a delay of a few seconds. Not critical, but noticeable. A video call conversation will be intermittent, similar to bad internet. Email, messaging, normal, but live dialogue is difficult. Astronauts will record video diaries, share news on social networks if allowed by the program. But the main communication is within the team, and here psychological compatibility is critically important. A conflict on the moon cannot be resolved by going to another room or taking a vacation. You are locked together for months. People are needed who can control emotions, find compromises, work in a team. Children on the moon is a question of the future and very controversial. No one knows how pregnancy and fetal development occur in conditions of low gravity and increased radiation. Experiments on animals in orbit have shown that it is possible, but with complications. Bones form incorrectly, muscles are weaker. If a child is born and grows up on the moon, they will not be able to return to Earth. Their body will not withstand Earth's gravity. This is an ethical dilemma. Do we have the right to create people who are forever tied to another world? Or is this a natural step of evolution, the appearance of a lunar generation adapted to its environment? Education on the moon will be virtual. Teachers on Earth, classes via video link or AI assistants that adapt to the pace and style of the child's learning. Entertainment, virtual reality, games, movies, books. Maybe there will be gyms adapted to lunar gravity. Imagine basketball where the ball flies 6 times higher and slower, or acrobatics where you can do somersaults that are impossible on Earth. This could become a new sport. The economy of the base at the initial stage will be fully subsidized. States pay for the maintenance of astronauts, for supplies from Earth, for the development of technology. These are investments in the future, but without an immediate return. Gradually, when mining and selling of resources begins, the base will start to pay for itself. The first income will come from selling fuel to other space missions, then maybe from tourism. There is a demand for lunar tours among billionaires and simply rich enthusiasts. A week-long trip to the moon can cost tens of millions of dollars, but there are people ready to pay. A tourist module with panoramic windows, an excursion on a lunar rover to historical sites like the Apollo 11 landing, the ability to jump in lunar gravity. This is a unique experience. But the real economic value of the moon is not in tourism or even in fuel. It is in the fact that the moon is the gate to the solar system. Each mission to asteroids, to Jupiter's moons, to the outer planets must pass through the moon. Not necessarily physically, but logically. If you have a base on the moon where you can refuel, repair a ship, replenish supplies, add crew, this reduces risks and costs for deep space missions. The moon becomes a logistics hub, a spaceport, and whoever controls this hub controls access to the resources of the entire solar system. Asteroids contain platinum group metals, rare earth elements, nickel, iron in quantities that exceed all of Earth's reserves. One average metal asteroid can contain trillions of dollars of resources. Mining technology on asteroids is complex, but not impossible. You send a robot that lands on an asteroid, drills, collects material, and sends it back to the moon or Earth's orbit. Processing takes place at orbital plants. Metal is used for the construction of space stations, ships, solar power plants. Nothing needs to be brought from Earth. All industry is in space. Jupiter's moons, Europa, Ganymede, Callisto, contain a huge amount of water under the ice. These are potential bases for exploring the outer solar system. But to get there, support is needed. A mission from Earth to Jupiter will take years. The ship must carry all the fuel, all the equipment, all the food. This makes the mission incredibly expensive. But if you start from the moon, where fuel is cheap and gravity is weak, costs are reduced. The moon is a springboard. Colonization of Mars is impossible without the moon. Mars is hundreds of times farther. Conditions there are tougher. Return is more difficult. Before sending people to Mars for years, you need to make sure the technologies work. You need to test everything on the moon. Life support systems, food production, water extraction, construction of shelters. If something breaks on the moon, astronauts can return in 3 days. If something breaks on Mars, they are dead. The moon is a laboratory where we learn not to kill people in space. Therefore, the fight for the moon is not just a fight for a rock in the sky. It is a fight for the future of humanity in space. Whoever controls the moon controls the paths of expansion. This is geopolitics of the next level, not borders on maps, but borders in the void. Not oil fields, but ice fields. Not fleets on oceans, but ships in orbits. The United States understands this. The Artemis program is not just a return to the moon. It is a bid for leadership in space for the entire 21st century. If the United States builds a base, creates an economy, attracts allies, they will set standards. Technical standards for docking ships, communications, power systems, legal standards, who can mine, where you can build, how to resolve disputes, cultural standards, language, education, values. This is soft power that lasts centuries. The English language became global thanks to the British Empire and then American hegemony. If the United States is the first to create infrastructure in space, English will become the language of space. China understands this too. Their program is not just a duplication of the American one. It is an alternative model. Centralized planning, state control, long-term strategy without regard for elections and changes of administrations. The Chinese Communist Party can plan decades ahead without worrying about political cycles. This gives an advantage in projects requiring patience and consistency. If China builds a base, attracts allies from developing countries, offers them access to space technologies in exchange for political support, the balance of power will shift. Space will cease to be a zone of Western dominance. Europe in this race plays the role of a mediator. The European Space Agency cooperates with both sides. They provide modules for the Artemis program, but also discuss cooperation with China. Europeans do not want to choose a side. They want to be independent players. They have the technology, experience, infrastructure, but they lack political will and financing for an independent program, so they balance. Russia, after the collapse of the Soviet Union, lost most of its space potential. Roscosmos is still capable of complex missions, but the budget is limited, technologies are aging, corruption eats up resources. Partnership with China is an attempt to stay in the game. Russia provides expertise, China, money, and production. But this is an unequal partnership. Over time, China will overtake Russia technologically, and the need for a partner will disappear. India is developing its program independently. They successfully reached Mars's orbit on the first attempt. The cost of the mission was laughably low by Western standards. The Indian Space Agency is efficient, engineers are talented, ambitions are growing. If India decides to focus on the moon, they can become an important player. No, so far their priorities are blurred between the moon, Mars, and low Earth orbit. Private companies add another layer of complexity. SpaceX, Blue Origin, Rocket Lab. Dozens of others do not obey states directly. They work on contracts but also have their own goals. Elon Musk openly says that his goal is to make humanity multiplanetary and Mars is his priority. But Starship, which he is building for Mars, is ideally suited for the Moon. NASA has already ordered a version of Starship for landing astronauts in the Artemis program. If Musk gains control over lunar logistics, he will gain enormous influence. Jeff Bezos is less public, but no less ambitious. His vision, millions of people living and working in space, while Earth turns into a nature reserve. Blue Origin is developing technologies specifically for the Moon because Bezos believes the Moon is the key to the industrialization of space. He invests billions of his own money without expecting a quick return. This is a long-term bet. And here all these players, states, blocks, companies, billionaires collide on the Moon in conditions where rules are not defined. This is a recipe for conflict, but it is also a recipe for progress. Competition stimulates innovation. States and companies spend billions on developing new technologies because they do not want to fall behind. Each success of one side motivates the other to double its efforts. It is a race, and races make participants faster. But there is a danger that competition will escalate into confrontation. History is full of examples when the fight for resources led to wars. Colonial empires fought for territories. Oil companies financed coups. Countries invaded neighbors for water and land. The Moon could become the first extraterrestrial battlefield if we do not establish rules in advance, and time for this is limited. The first permanent bases will appear in the next decade. By that point, a legal structure is needed. The UN is trying to play a coordinating role, but its capabilities are limited. The Committee on the Peaceful Uses of Outer Space has been discussing these issues for years, but there is no consensus. Russia and China want a new treaty that will replace the outdated document of 1967. The United States and its allies prefer to work within the framework of existing agreements, supplemented by bilateral and multilateral arrangements like the Artemis Accords. This is a dead end. And while diplomats argue, engineers build rockets, and the clock is ticking. Perhaps the solution will be the creation of an international lunar organization, similar to the International Atomic Energy Agency. An organ that monitors compliance with the rules, resolves disputes, certifies operations. Countries and companies wishing to work on the Moon must register their plans, obtain permits, and report on activities. This does not limit freedom, but creates transparency. If everyone knows who is doing what and where, the probability of conflicts decreases. If disputes arise, there is a negotiation mechanism, an arbitration court, sanctions for violators. But to create such an organization, political will is needed, and it is not there yet. The United States does not want to share power. China does not want to obey rules written in the West. Russia demands equal status but does not have the resources for a significant contribution. Europe wants a compromise but cannot force the major powers to agree. India, Japan, other countries want to participate but do not want to be drawn into bloc politics. And in this chaos, real work begins. Robots are drilling for ice at the south pole of the Moon. Astronauts are testing next-generation spacesuits. Engineers are designing nuclear reactors the size of a suitcase for lunar bases. Biologists are growing plants in simulated lunar regolith. Programmers are creating AI to manage autonomous systems. Thousands of people around the world are working to make the Moon habitable. They do not care about geopolitics. They care about the task. Solve the problem. Make the technology work. Test the hypothesis. And in this, there is hope. Because despite all the politics, all the conflicts of interest, space unites. Astronauts on the International Space Station, Russians, Americans, Europeans, Japanese, work together, sleep in the same module, eat together, help each other. There are no borders there. When you see Earth from space, all these borders, flags, conflicts seem an absurdity. We are all on one small planet flying through the infinite void. And if we do not learn to cooperate, we will not survive. The moon could become a symbol of this cooperation. Not an American moon, not a Chinese one, but a human one. A place where people of different countries, cultures, languages live and work together because the alternative is death. In space, there is no room for nationalism. Technologies work or do not work, regardless of who created them. Everyone needs oxygen, everyone needs water. Radiation kills everyone equally. This levels things out. Maybe in 50 years, when there will be dozens of bases on the moon, thousands of people, children born there, an economy, a culture, we will look back and realize that the geopolitical struggle of the 20s and 30s was the last flash of Earth thinking, and then something new began, space thinking. We stopped dividing planets into territories and started looking at them as common resources. We stopped considering ourselves citizens of countries and started considering ourselves citizens of the solar system. This is a utopia, maybe. But utopias drive progress. The idea that people could fly was a utopia until the Wright brothers built an airplane. The idea that we would reach the moon was fiction until Armstrong left a footprint on the regolith. The idea that we will live outside Earth seems impossible now. But in 100 years, our descendants will live on the moon, on Mars, on orbital stations, and for them it will be as natural as it is for us to live in cities. But for this to happen, you need to go through a difficult period of formation, through conflicts, mistakes, tragedies. People will die. This is inevitable. Space does not forgive mistakes. A spacesuit accident, a life support system failure, a pilot error, a solar storm. All this can kill. We will lose astronauts. It will be painful. Society will ask the question whether it is worth it. And every time we will have to answer, yes, it is worth it. Because the alternative is to stay on Earth forever, and one day something will happen. An asteroid, a supervolcano, a pandemic, a war, and humanity will disappear. The moon is the first step to the immortality of the species. Not in the literal sense, but in the metaphorical one. While we are on one planet, we are mortal. When we are on many planets, we become almost invulnerable. To destroy a civilization distributed across dozens of worlds is almost impossible. Even if one planet perishes, others will survive. This is insurance at the species level, and it starts with the moon. Therefore, the fight for the 8th continent is not just a fight for resources or prestige. It is a fight for survival. And in this fight, there are no losers if we all reach the goal. Because the goal is not the victory of one country over another. The goal is to make humanity a space species, and every step toward this goal, every rocket launch, every astronaut who steps on the moon, every kilogram of extracted ice is a victory for all of us. The Apollo program was a brilliant dead end because it was based on an unsustainable model: disposable rockets, short-term missions, lack of economic logic. But it proved that it was possible. It inspired a generation. It showed that the limits of human capabilities are much wider than we thought. And now, 50 years later, we are returning, but now with a different approach. Reusable systems, long-term presence, an economic model based on resources. We learn from mistakes. We build on the foundation laid by the previous generation. And this is the main thing. Each generation takes a step. The generation of the 60s proved that you can fly to the moon. The generation of the 20s and 30s will prove that you can live there. The generation of the 50s will build an economy. The generation of the 70s will expand to Mars. Each generation passes the baton to the next. And someday, centuries from now, our descendants will settle throughout the galaxy, and they will remember that it all started here, on the moon, in the first half of the 21st century, when humanity made the choice not to stay on Earth, but to go further. Is this romance? Yes. But romance moves the world. Without the dream of flight, there would be no aviation. Without the dream of the stars, there would be no cosmonautics. Without the dream of the future, there would be no progress. We are dreamers, And that is our strength. We look at the moon and see not just a stone, but a home. We look at Mars and see gardens. We look at the stars and see a path. And we go along this path despite all obstacles because we cannot do otherwise. It is in our nature. We are researchers, discoverers, builders. We create the future with our own hands. And the battle for the 8th continent is part of this process. It will be dirty, difficult, full of conflicts and compromises. But in the end, we will build something great. Not because we are perfect, but because we have no choice. Space calls, and we answer. The moon waits, and we go. The future is open, and we create it. So next time you look at the moon in the night sky, remember, it is no longer a dead world, but a battlefield, a construction site, a hope. There, at the South Pole, under a layer of ancient ice, is hidden the key to our future among the stars. And humanity, despite all disagreements, is slowly but steadily moving toward taking this key and opening the door to the space age. The battle for the 8th continent has just begun, and its outcome will determine what kind of civilization we will become, locked on one planet or a species freely traveling between worlds. The choice is ours. Rockets are ready, technologies are developed. It only remains to decide. And apparently, we have already decided. The moon is our goal again, and this time we are staying. If you were interested to learn about how a new chapter of human history is unfolding on the border of Earth and space, support the Sleepy Scientist channel with a like and subscription. Ahead of us are dozens more stories about how science, technology, and human will collide with the boundless expanses of the universe, opening for us the path to the stars.